break your project, that's a bit obvious, but you also check that you don't break other projects. When we test a change in OpenStack, we actually deploy all the components together, and we test that all the functionality that you propose I mean, the rest of the functionality is not broken. You may think that your change will not impact other projects, but that ensures that it doesn't impact other projects. Also gives you a good baseline, an always good base. You basically know that if it's in the main branch, if it's in the master branch today, it passed those tests when it got merged. So it's basic quality baseline that you can build on top of. The fourth principle is time-based releases. So since we are an open innovation project again, we can't really predict or ensure that a given feature will make it to OpenStack in a given time frame. So rather than doing a very bad job at doing feature-based releasing and pray for people to hold their promises and hope that they will actually deliver what they promised they would deliver on time, you should embrace the benefits of knowing when the code will be released. And those are, rather than doing a very bad job at feature-based releasing, you should just embrace the benefits of doing time-based releases. And those are coordination benefits mostly. You have a number of downstream consumers of the project that need to know when it will be released, and marketing, QA, documentation, distros, companies that build a product on top of OpenStack, deployers of OpenStack, they need to plan their work in advance. Knowing when the release is available is actually more valuable to them than the exact content in features. For me, in the release management position, it's the concept of cycle is actually more interesting than the concept of release. That means we create a rhythm that the development community will follow. So everyone is on the same schedule, rather than everyone having a different schedule based on the project they're working on, the company they're working for, and various other combination of factors. It's a common breathing rhythm in a very diverse community that we have, and it's actually quite essential to get any work done in OpenStack. The last principle is that we should automate everything. So for the same reason that we we cannot really force people to do the boring tasks because they will just pick another task. The idea is to automate everything, and including the boring tasks, so that nobody has to do them. So in some cases, it's not really efficient. You may spend a lot of more time to automate the boring task than to do the boring task in the first place, but it's also 10 times more interesting to automate a task than to do a boring task. So we can actually find resources to automate boring tasks, but we can't find resources to do boring tasks. So that's the last principle we're following. Those 5 principles derive into 3 base processes. The first one is the release cycle. So we do 6 months release cycle. The cycle starts with a design summit, where it's 4 days during which we try to gather all of our contributor community. We have various different sessions. There are sessions to brainstorm new ideas. There are sessions to discuss implementation details. There are sessions that are the most important type of sessions, according to me, is the sessions where you put different groups working on the same goal but having different implementations. You put them all in the same room and you try to get them to converge onto a single implementation. And the miracle is that it actually works. If you put different technical groups into a room and you tell them that they're wasting effort and they should rather be working on the same thing rather than on different things, they usually end the session with a plan to converge towards a given implementation. So that's the design summit. After the design summit, the PTLs try to gather the commitments of various contributors and try to get a basic plan for the cycle with major objectives and publish it. Then you have, we publish milestones every 6 weeks. So people work on changes get merged. Every 6 weeks we put a tag on it. And that milestone actually also serves as a reference point in time. We also coordinate the community using those milestones. We say, well, this will be done by Juno 2, or I will take vacation between Juno 2 and Juno 3. It's a way to create a common sense of time across our contributors. And then there is the last milestone, which corresponds to feature freeze. So at that point, 6 weeks before release, we stop accepting new features. And we come up with a list of release critical bugs. We fix them. When they're all fixed, we issue a first release candidate. And then unless new regressions are found in that release candidate, we will publish that release candidate as the final release on the release day. And the second process is the journey of a proposed feature. So we start with a design phase where someone will write a spec. That spec will get reviewed by core reviewers by anyone who wants to review it, but also by the core reviewers of the project, and will finally get accepted. That person will write code, submit the change to Garrett, which we've been talking about in various other sessions today. Garrett will trigger a number of tests in the OpenStack infrastructure to check that you don't break anything. We'll see this on the next slide. Then you have humans looking at your code if that doesn't break anything. And then they approve it. It goes back to tests to refresh the status of tests. It goes to the gate and gets merged if it doesn't break in the process. And then it lands in a milestone and in the final release. So that's all the steps you have to go through to push a new feature inside OpenStack. In a bit more detail, this is the code merging process. So you have developers that will clone a branch from a Git repository, get a branch here, work on their code at some point, propose it for review. The code will automatically get tested for a syntax test, language tests, unit tests, integration tests with all the other components. Then humans will review it. It might go back and forth a few times here. Every time you propose a new version of the change, it gets tested again. And at some point, it gets approved. Then it gets tested again. And if it still works, then you end up in the master branch. We create a tarball from it, and we mirror it over onto the Git repositories. So that's the process that all our changes follow. Okay, 17 minutes, not too bad. Challenges. So up until now, I talked about the principles and the processes we follow, but we actually encountered a number of challenges, mostly due to the growth of the project, and I want to go through them now. The first challenge is chaos. Since nobody knows what will be in the next release, there is no roadmap, there is no clear objective. It's a bit, how do we work? I mean, how do we get anything done in this project? So it's part of the role of the release manager or the release management team to try to make sense out of chaos. It is try to predict the features that will be in the release with a reasonable amount of certainty. And that's about communicating with the PTLs, asking them what's likely to land, what's being worked on, if they trust the person the job is assigned to deliver on time. And then we publish a list of features that we think will get with a reasonable amount of certainty in the next release. It's not exact science, but it's still a valuable tool for downstream consumers of the project so that they know what will probably get in the next release. The second challenge is task tracking across various groups. So OpenStack is huge. We heard numbers of hundreds of contributors contributing to the last release earlier today. The problem is this is not a single group. Those are separate groups working on separate pieces of OpenStack. And in some cases, some tasks require that you, some tasks require that you coordinate work items across different teams. And for bugs, we're using Launchpad, which provides a nice abstraction where you can have a single bug and then multiple tasks that affect different groups. But we don't have that for features because Launchpad doesn't support the same abstraction for feature tracking. And we also have so many groups involved that we actually hit scaling limits within Launchpad in the number of tasks that you can have in a bug. So if you have like more than 5 or 6 tasks, the thing starts to fall over and timeouts all the time. So we actually need a new tool that would provide the same type of abstraction. And because the problem is not just scaling of Launchpad, it's actually architecture inside Launchpad. So we are working on a tool called Storyboard that will allow us to apply the same abstraction that Launchpad has for bugs, but also for feature tracking. That means we're encountering challenges, and you will see that in other slides. We're encountering challenges that don't have a solution in the open source world, and we need to create our own tools to solve those challenges. The next challenge is gate congestion. So if our test run takes about 1 hour to run, a bit more today, and if we just tested changes serially, like one after another at the gate to check that we don't break the current state of the branch, then we have a problem because we can only merge 24 changes per day. And that might be acceptable for most projects, but it's actually totally unacceptable for us because you will see numbers afterwards, but we are far above that limit. So we need to invent smarter ways of doing gating than serial gating. And so we had to write our own tool called Zool, which others can speak better than me about. It's a tool that will test a series of changes assuming that the ones before them succeeded in testing. So you parallelize the tests, but you don't just parallelize them. You will test the first one, then the second one, assuming the first one succeeded, then the third one, assuming the two previous ones succeeded. And then if they all pass, you can actually merge stuff very fast. If there is one that breaks, that slows down the gate. But at least you start testing in parallel rather than purely serially. And Zool allows us to do it in a consistent way from a QA perspective. We still test the change on top of the current state of the branch and not, so we avoid regressions due to concurrent changes. That's another example of a tool we had to create to solve unique challenges in OpenStack. And the next challenge is rare issues. So if you have like a race condition in your code, an issue that only happens once every 1,000 runs, then you have a problem because the gate might allow it inside the code, but because you will get lucky when it gets tested, and so that rare issue will be present in OpenStack code. But actually, with the volume of tests we're running, we're also able to detect those issues, even if they are extremely rare. So there was a very interesting presentation by Sean Daig at the Atlanta Summit with lots of examples. If you run enough tests, you can actually detect those rare issues. They will trigger false negative in the test, but they will actually represent real issues that you need to fix in your code. So we can use the whole elastic recheck infrastructure that we created to detect those issues, and we can actually detect issues that happen once every 10,000 runs in OpenStack. We came to fix issues that were actually race conditions that had 0.01% chance of happening in the code. So it's actually a QA tool, and we turned a problem into a great QA story. It also gives you an idea of how reliable our infrastructure actually is, because we also encounter a problem within the infrastructure. Like we realized that GitHub was not that reliable, and if it's down like 40 seconds per day, you will have 15 tests per week in OpenStack that will fail due to GitHub reliability. So we have basically to mirror everything that GitHub does internally so that we don't rely on GitHub, so that we don't have those 15 changes get rejected in the test while the change was okay, but the problem was a GitHub reliability issue. So we end up running a pretty reliable infrastructure also due to the volume of tests we are running. The next challenge is community center and focus. So the problem is with so many cats or lambs, it's difficult to assume a common culture. They will come from a lot of different backgrounds, corporate backgrounds, cultural backgrounds. So to make sure that people don't go in every direction, we need some artificial tools to focus them in the right direction. And that's part of the explanation of the focus on the Python language. We enforce single style through the PEP8 coding style guidelines. We also try to reduce friction within our development community by providing them the tools that are appropriate for their job. So like they don't do code reviews on a mailing list, they do code review in a code review tool. And that allows us to not have our community spread around in every direction and have them focus on the right challenges rather than create a problem just due to the size of and variety of our contributors. Next challenge is the water cooler effect. So that's something that the open source people in the room might know about. It's the idea that you need, if you have enough contributors coming from a single company working from the same office, they might just take decisions around the water cooler rather than on mailing lists where the rest of the community can see them. And that, I mean, there are some projects in OpenStack that have a significant group coming from the same company and potentially the same office. So we risk to have, or the same region, if you take like Silicon Valley, which is far away from here. So to reduce the risk of that challenge, we are enforcing openness in our integrated projects. So before a project is accepted for integration, we make sure that it's coming from a number of different companies and not a single group that knows each other very well. We also enforce that discussions happen on mailing lists. We enforce that meetings happen on IRC and not on Hangouts or physical meetups in the Silicon Valley area. And that's because it's really easy for people that are using those tools, especially English-speaking and extrovert people, to think that it's the best way to communicate. But for the rest of the world that doesn't speak English as their native language, it's actually much more comfortable to have the discussion in IRC than to have a hangout where it's the most vocal person that will win the argument at the end of the day. And the last challenge is anger. It's the risk that when you operate in a purely virtual community, you have limited hints from the body language of the person you're interacting with, and it's very easy to get pissed by someone that doesn't behave correctly over a mailing list or has strong opinions on IRC. And if you don't do anything, your community will quickly get destroyed by that amount of anger that slowly builds up in your community. So what we do is we use design summits to get all the developers, or as many of the developers as we can, together so that they would reset regularly those personal issues and realize that the guy they're having a beer with is actually very nice. And usually in person, everyone gets along, whereas through a mailing list discussion, it can be much more difficult. So those are the challenges. I'll go through a set of numbers. You've heard numbers from others today. They will be slightly different because we all have a different set of data we're working from. But on a typical weekday, we're having about 1,000 patch sets proposed. That's a version of the patch. So it might be a new change, might be a new patch set. That's across all the OpenStack project, not just the integrated projects. Also infrastructure, it's also documentation. It's also QA. We have about 7,500 Gerrit comments and votes. So granted, like half of them are automated votes from machines that report test results. But still, it's quite amazing to imagine that we have so many people commenting every weekday on proposed changes. Those proposed changes result in 16,000 test runs. Most of them will spin up complete OpenStack installations to run in the Tempest integration tests on them. And finally, those 16,000 test runs will result in 250 changes merged into the OpenStack code. So that's about 100 changes in the integrated projects alone and 150 other changes. That makes OpenStack arguably the biggest open source project in activity today, and some are actually arguing that it's also the biggest software development project today. Thank you. Questions? Florian, you have questions. Yeah, I also have an You want to get home early? Sure.
Are the tools available for other projects? Ones you mentioned, Storyboard was one.
It's a good question. So all the tooling we're using for OpenStack is open source, and all the tooling we create for OpenStack is obviously open source as well. So Storyboard is developed within the infrastructure team. So it's one of those 130 different code repositories I've been mentioning. And not only is it possible to do it, it's actually being done by a number of companies. The model we've been building with all the infrastructure, this presentation was not strictly about infrastructure, but from the infrastructure perspective, the tooling we've been combining together is actually reused by a number of different companies internally with the same model being applied. And some companies are even making products around the packaging of those different tools so that people can just consume the prepackaged set of tools. So it's being used and it's open source. It's all the configuration around it is also open source. So all the Puppet recipes you can use to deploy them are open source and published in the Git repository. All the changes for this infrastructure go through our code review system, so it's all transparent, all reusable, and you have all the keys. You just need to set your own database password, basically. So, well, thanks for your attention.